Yo, what is good, dev guys? Welcome back. In this video, I want to get started with the setup for our grenade ability. No one typed into the chat or said anything in the comments about what they wanted to see next, so I guess I'll just go with what is going to take us the most time and also set us up for the most things in the future as well here. So we got a lot of coding to do. I hope you guys are ready. Let's jump right into it. I am actually going to close the editor down. We're not going to do anything inside the editor right now. So the first thing we need to do is create a task that will allow us to use our first person arms as a means of activating events and doing things like montages and things like that. Because right now there is nothing in this code base that will allow us to use our first person arms to play montages or anything like that. It all works off of a third person mesh. So we need to come into the Lyra game ability system. And one thing I'm going to do is right click inside of here and I'm going to add a directory. If you're using Visual Studio, good luck. Figure out how this is, correlates to Visual Studio. I'm not really sure, but just add a directory and I'm going to call this tasks. And inside of task, I want to add an Unreal class of type U object, and this is going to be our ability task where we will play a montage on a mesh and wait for event. So I'm gonna call it play montage on mesh and wait event. That's the name of this class here. So get this class created and make sure that it derives from U ability task. You can see here, if you don't have writer, you need to declare in the header ability task.h. So you need the hashtag include ability task.h. So let's do that. And before we even go forward with that, we need to come over to our ability system component. And where is that at? Where is that actually? I'm about to just type it in here. I'm gonna search for Lyra. Well, let's just search for Lyra ability system component. And I am blind as a bat. This is another reason why I organize my classes, because this is a lot of classes to try to filter through. I don't want to be doing that. So I am going to close all the other tabs. And way down here at the bottom, what I'm going to do is create another region. And this is just going to be for custom code. Oops. Okay. And we need a few functions in here. And when I say a few, I mean almost 10, 15 functions, man. So instead of typing this out line by line, what I'm going to do is copy the functions over and we're going to implement them. And I'm just going to walk you guys through what the code does. And because I'm looking at how many functions there are right now, and it is breathtaking, to say the least. And so what I'm gonna do is just copy these over. So the first one we need is play montage for mesh. That's going to be virtual float, play montage for mesh. And basically what we're doing here is we're creating our own versions of these montage functions that are already existing in a UANA montage class, but we're making them so that we can pass in our own custom mesh to do that. The next thing we need is this puppy here, play, and what I'm gonna do is extend this so you guys can see. So the first one is a virtual float, play montage for mesh. It takes in an animated ability. This is a U gameplay ability pointer. It takes in a U skeletal mesh component, call it in mesh. It takes in an F gameplay ability activation info, and this is our activation info. It takes in a UANA montage pointer, call it montage. It takes in a float for the play rate. It takes in an F name for the starting section name, and we default it to name_none. And then it takes in a Boolean to whether or not we want to replicate the montage. This is by default set to true. For this next function, virtual float, play montage simulated for mesh, it takes in the skeletal mesh, in mesh, UANA montage. It takes in a float for the play rate and also a F name for the section name, and it's defaulted to name.none or name_none. For this next function, we need a virtual void, call this current montage stop for mesh. So it takes in a mesh, a skeletal mesh component pointer, and it takes in a float for our override blend out time. and default that to -1. This next function is going to be virtual void stop all current montages. This is just going to take in a float, call it override blend out time, and default it to -1. Another function here that we need, a virtual void stop montage if current for mesh. And then it also takes in a constant UNA montage reference for the montage. And then also another float for the override blend out time, and set that to -1 by default. Then we want another function. This is going to return void. It's going to be virtual void clear animating ability for all meshes. And this is just going to take in a gameplay ability component. So as you can see the comment here, it clears the animating ability that is passed in if it's still currently animating. Next is this puppy here is a virtual void function. It's current montage jump to section for mesh. The next function is a virtual void. It says current montage set next section for, we set the next section name for mesh. The next function is this one here, the virtual void current montage set play rate for mesh. So this will just set the play rate. This next function is returning bool, and this is animating ability for any mesh. This just determines whether or not we're animating a montage or basically if we're animating a montage for an ability at the current time. This next function, this returns a gameplay ability pointer, and this is get the animating ability from any mesh. This next function, this returns a T array of animontage pointers, and this is get current montages. The next function is just going to return us an animontage pointer, and this is going to say get current montage for a mesh. This next function, get section ID of the currently playing animontage. In the same lines of that, we want to get the section name of the current montage playing here. This next function returns a float, and it go ahead and it gets the current montage section's length for the mesh that we're passing in here. And then the last one I want to do in this video is this function here where we get the current montage section time left for the mesh that we pass in here. So I'm going to implement all of these. So Alt Insert, create definitions, and you see here, that's how many functions? Jesus Christ. Looks like 20 functions almost. I can't really tell. So I hit OK on that, and we're going to go ahead and create the definitions for that. And what I want to do is Control X those right now, just right off the bat, and come back down here and make a region. Hashtag reach. There we go. And if you guys don't have the hashtag reach, that's my own custom snippet. But basically creating a region is hashtag pragma region and then hashtag pragma in region. I just made a quick little snippet so I didn't have to type that out. So let's call this custom code for the section name or for the region name, and then I'm gonna paste all that stuff back in there. Then I'm gonna do some formatting here. I kind of don't like when it comes down to the second line. It confuses me a little bit. So I just put everything from the function, like the parameters, I put it all on one line, no matter if it goes off the page or not. And I guess they do this because this line here is telling it like how far it should go before it goes to the next line. But for me, I like to just keep all that stuff on one line so I don't get confused. And let's start at the top here with our play montage for mesh. This is a very long function, so I'm going to copy it here and just walk you through all the steps of that function. So as you can see here, we got a few functions that we need that we haven't written yet. And I guess what I could do is just write all the functions, and that way we're able to see this compile successfully, or not, because we won't even compile in this video. I'm not gonna lie to you. I'm looking at, like, when I look at this, the project that I'm using, my main project, and there is like 40 functions that you need to get this system up and running. So I'm gonna continue with this, typing in these functions here, just so that we have all the functions, and then we'll implement them section by section as we need them. But as long as they're typed out, we should not see any like red squigglies. So this next chunk is not too bad. It's not as many functions as previous. So let's just go ahead and start with it. We need a U property, and this is going to be a bool, and we're going to call this B pending montage rep for mesh. So if this value is true, that means that we have a montage that is pending for replication, and we need to go ahead and do something about that. We also need, and let me copy the comments here. So if you guys want to also copy the comments, you can. We also need a T array here, and it's going to be of type F game playability local and a montage for mesh. But you see here on my screen, it's red out. So that means I don't actually have this struct. So let me go ahead and pull it over here. Okay, and I'm gonna paste the struct up here. There's actually two structs. And if you guys are wondering, like, where in the world is he getting all this information from? Like, how does he know this? I'm not like some genius. There is a project that has a lot of good code for different things that you would do in gas with first person. And pretty much this task is literally like the code that we're typing now inside the ability system component, and the task that we're going to type in the next video is completely copy and pasted from this project here. So if you want to look at a more in-depth explanation, this gas documentation actually has like documentation on gas in depth. So if you want to take a look at that, definitely I'll give you a link to this GitHub repo in the description of this video. So yeah, I'm not like some super genius. I just know where to find answers. So this first struct is a data about montages that were played locally. And it says here, all montages in case of server, predictive montages in case of client. And it's never replicated directly. So this is our F gameplay. And it, of course, is a U struct. And we're just calling the struct F game playability, a local and a montage for mesh. Under the generated body, we have a public section that has a U property for a U skeletal mesh pointer, a U property for F game playability, local and a montage. And this is the actual struct here that we're kind of following here. So this is an actual struct inside of game playability types, and we're following that inside of here, or we're kind of, I don't want to say childing that struct, but we're using the base of that struct to also extend what we need for this struct. And then we just have a couple of constructors for this struct so that we can construct it different ways. So with that inside of the header file here, we'll come back down here, you'll see that this is no longer redded out. And now we can continue with copying and pasting here. So this next property, we need a T array of replicated meshes. So this is using that struct up top. So this is giving me an error because I'm saying replicate using, but I don't have this function created yet, so don't worry about that too much. But this is using the other struct that we have up here, and this is the replicated version of this, which is using the replicated version of the parent type inside of game playability types.h as a like a housing. Basically, this is a T array that we're going to fill up and queue up for all of the replicated montages that we so deem should play. Then we need a function here. This function is going to return one of this F game playability local and a montage from mesh structs. It's going to return a reference to it, and we're going to pass in a mesh, and that way we're able to pull this off of the mesh that we sew the side to. And then we want to do the same thing for the replicated version of that struct. The next function is this void on predictive montage rejected for mesh function here. So now we need this other function here, and this is going to copy our local anim montage info into the replicated montage info. So basically that's where we're taking the data that we put inside this local struct and copying it into a replicated struct so that we could send that up to the server and it'll do what it needs to do with the replicated mesh. The next function is copying over playing flags for a duplicate animation data. I was telling you guys that this is a landmine field, and it really is, man. Like some of these functions, they make it easier to read inside the CPP file, and they handle like certain chunks on their own. It's like, what does this function do? What does this function do? But it gets really hard. So here's our on rep function that got rid of this error that we had here. So That is why we have the U function declaration on top, because, you know, on rep functions need to have this U function on top. For this next function, we need this virtual bool, and this is ready for a replicated montage for mesh. So this next function is an RPC, and this server function will go ahead and get called from our current montage set next section name, so that if we are replicating a montage, that when we predictively call this on the client, we actually also call it on the server, so that other clients can see that we are moved on to the next section for our montage. This next function is also a server RPC. This is called from the current montage jump to section. So this is keeping us in sync when our client says, okay, I want to jump to the next section. It also will call the server function as well and jump to the next section as well on the server version, so that it's replicated to the other client. And then this last RPC is so that our play rate is also in sync across all clients. This function is one of my own functions. It's just executing the gameplay queue on the owner. So yeah, going back to this play montage for mesh here, and we don't have the function called set current montage for mesh. Okay, so in the actual gameplay ability class, there's some code that we need to write as well. So like I said, it gets deep, guys. Eventually all this stuff will come together. So we need to navigate to our gameplay ability.h, and we need to go ahead and I'm gonna move this over to the left because it might not be as important. And luckily for this class, it's only a couple of functions, so it's not too bad. So I'm gonna come all the way down here to the bottom. You know what I'm gonna do? I'm gonna make a region, call this custom code. So I'm going to copy again here what this is doing. This first function is get current montage for mesh. And then this next function that we need is going to be called set current montage for mesh. This is the one I think we're actually trying to call here. So that removes that error. But I just want to get all of these all this montage stuff set up and put in correctly. On the top of this class, we also need a struct that will hold the data for our montage and our ability. And we're going to call this F ability mesh montage. It's going to have a U property that is a skeletal mesh, and also a U property that is a pointer to a montage, and then a couple of constructors to allow us to construct this struct in different places. Then that will allow us to use a U property of that type that will be a T array of that struct, and this is our current ability mesh montage. So next we need a function that returns a bool, and this is going to find the ability mesh montage. Next we need a function called montage jump to section for mesh. Next we also need called the montage stop for mesh. Last function we need is this montage stop for all meshes. So this will stop all montages playing on every single mesh that we have active inside of our character. So with those typed out, we're actually able to make some progress inside of this ability system component. So now I could step you guys through here now that we don't have any errors. So the first thing we're doing is casting the incoming ability to our Lyra gameplay ability, so that we make sure that we're using the type that has access to all the things that we need. Then we're setting this float duration to -1.0. So in this line, we're basically doing what a select node would do. And we are setting the pointer to this anim instance here, this uanim instance. We're setting it based on whether or not our mesh is valid, the incoming mesh from this function here, whether that's valid, and that our get owner is equal to the avatar actor of this ability. So in the beginning, when the ability is given, it'll set its ability actor info, which will pass in the avatar actor and the owning actor. And if that's not the same as the owner of this mesh, this will fail. So depending on that, that's what this question mark is. We want to say, get the anim instance of the mesh. If not, return null pointer. And then we do a check here to make sure that we have an anim instance and a montage. This montage, it comes in from this input parameter here. And then we set our duration that we created up here. We set that equal to the anim instance montage play, which returns a float. And we give it the montage and the end play rate. So this will go ahead and play our montage, first of all, and then give us the duration of that montage that we just played, depending on the play rate that we set here. So here we're checking if our duration is greater than 0. We want to go ahead and create some local ability data here for our montage on this mesh. And we're using this function that we haven't really typed out yet. And this is not doing anything right now, so it's not worth explaining. And there's comments in here that kind of go over what this covers, but it's not really important. So this next check is checking if we have root motion enabled inside the montage, and if our anim instance get on an actor is valid. If that's true, we need to go ahead and log. Next, what we're doing here is we're just setting that new local data to the current montage that's playing. So that struct holds a montage U property, and we set that equal to the montage. It holds an animated ability property. We set that equal to the animated ability, and then it holds the play instance ID. You can see here I put myself, I don't know what this is for. So this is part of coding where you would want to turn this off or not do this to see what happens. But basically this toggles the play bit on and off. Next, we check if our inability is valid. And then we say here, inability set current montage for mesh. That's a function that we just typed up on the ability, the gameplay ability class. And then what we want to do is make sure that our start section name is not equal to name.none. So if we actually gave this a name, then we want to jump to that section using our anim instance montage jump to section function. This is an actual function on the anim instance class. And like I said, we're wrapping a lot of stuff so that we're able to access it and tweak it the way that we need to. Then we do this replication to non-owners of this ability system component. So this is a function inside of the ability system component. It is the owner actor authoritative. This basically says, is this the version of the component that is on the server? If that's true, we want to also check if we want to replicate the montage, which comes in via the function call here. Right here, comes in via the function call. And if that is true, then we want to construct this replicated struct here that we want to go ahead and pass up to the server eventually. And then we want to set the montage value on it to the montage that we are using. And then we want to set the play instance ID, and we want to invert it, casting it to a bool. And this is a C style cast. This is just like up top where it's toggling the play bit on and off. Next, we want to take this anim montage update replicated data for mesh, call that, and pass in our mesh. This is a function that we typed, but we're not implementing that today. This next part here is forcing a net update. So this will basically tell the server to update pretty much every simulated client so that they are it's like refreshing the browser. Basically, it's basically telling the server refresh the browser and make sure that this gets pushed through as an update. So this else here, this is whether or not our actor is authoritative. So if this actor is not authoritative, we want to do a prediction key here. Now this prediction key, this is above my pay grade. I haven't tried to understand it, but I do know that it basically creates like a handshake between the client and the server about something that was predicted by the client that the server needs to replicate. That's like my understanding of it, but I just don't have like a deep understanding. And then basically if the prediction key is valid, we go ahead and set a delegate. If this is rejected, we want to know, because if it's not, everything will work. But if it's rejected, we want to know. So we're binding a delegate to this new rejected delegate here, and we're giving it the address of our onPredictive montage rejected for mesh function here. And we're giving it the mesh parameter and the montage parameter. And then once this is all over, we return the duration, which we set up here once we played the montage. And that, my friends, is just one function. You know what I mean? So now we want to talk about this play montage simulator for mesh. This one is a little bit easier to digest. So let me copy it and paste it over here and just talk through it. So this is the function that is called whenever a simulated mesh is playing a montage that we want replicated to us. First thing we'll do is set the duration, because remember, this is returning the float. We'll set the duration to a default of -1. Here we're going to do that same select type node thing here, where we're setting this pointer to an anim instance based off of whether this mesh is valid and whether or not the owner of the mesh is equal to the avatar actor that is on the ability. And if that's good to go, we want to set our anim instance to the one off of the mesh that we passed in. If not, set it to null pointer. And then also, once again, we check and see if these two things are valid, the anim instance and the montage. And we instantly set the duration equal to the float that returns out of this montage play function call here. And then if our duration is greater than 0.0f, we want to go ahead and construct some local data for ourselves. And we'll get the local data from the mesh that we passed in here. And then we'll go ahead and set our anim montage on that local data to the montage that is passed in through this function here. And then once that's all done, we'll go ahead and return the duration there. This next function, this current montage stop for mesh, is also a little bit more digestible. So let's go ahead and bring it over here. So once again, we're doing that select node thing here where we're basing our anim instance pointer off of whether things are valid and equal to what we have here. This is used a lot in this code, this select node here. So I'm not going to keep repeating myself on this. So once you see this question mark in any setting of a variable here, it's basically like using a select node in Blueprint. Then we go ahead and construct some local animation data for ourselves here using this get local anim montage function here. And we also create an anim montage pointer, call that montage to stop. And we set this equal to the montage that is on this local data. So this local data, if we have any here from this mesh, this will populate this struct here with the local data that is returned from this mesh. And then we're able to populate this anim montage, which can be const, to populate this anim montage variable here with the anim montage that's on that local data. Then we have this const bool, and this is called b should stop montage. And this is also set to whether or not our anim instance is valid and the montage to stop is valid, and our anim instance is not already stopping a montage. So if this is true here, this Boolean that we made, we want to go ahead and create a constant float, call that blend time, and set this equal to whether or not our override blend out time is greater or equal to 0. Because by default, remember, this is set to -1. And if it's greater or equal to 0, we want to go ahead and say use the override blend out time. But if not, just use the blend out time from the actual montage that we want to stop. Here we'll call anim instance montage stop. This is the montage stop function that we're wrapping around to stop for the mesh. This is the actual function that we want to call here. And this will go ahead and stop the montage for us using the montage to stop as a parameter and the blend time that we set up here. And if we are authoritative here on the component here, we want to say anim montage update replicated data from mesh. This is one of the functions that we haven't typed out yet or haven't even generated yet. So this is, well, we'll talk about what this function does when we get there. But if we look at the comment, this just copies the local to the replicated and sets it up to where we queue up some replicated animation data for the server to replicate. Next, we have this stop all current montages function here. And pretty much what we want to do is just iterate over all of the local data that we have cached here. You can see if we click on this, this is that U property This is the cached data. It's a T array of all of the local and a montage mesh data that we have here. So we iterate through all of those. And for each of them, we want to call current montage stop for mesh. And then we want to use the data's mesh parameter and pass it the override blend out time. This function is the function that we wrote up here. Okay, so next we have the stop montage if current for mesh. And this is very simple here. We just construct this local animation data for ourselves, and we populate it using this get local anim montage info for mesh. So if this returns something with valid info in it, we'll populate it here. We'll fill this variable, and then we'll go ahead and use that variable to check and see if our reference to our montage, and this is basically getting the address of the montage instead of a pointer to it. And I'm pretty sure that's to save on memory, because some of these montages could be crazy. You know what I mean? Like I said before, a montage can consist of multiple animation clips or animation, I think animation assets. I don't know what the term is in Unreal, but it's a bunch of animations that you can pile up in there. And to save on memory, we don't want to be passing around a copy of that all around the place. So here we just use the address of the montage that we pass in. And I might be saying this wrong. My understanding of C++ is not great, but I think that's what it is. So if this is equal to the montage that is on our local data that we pulled here, then we want to just say stop current montage stop for mesh, give it the mesh, and give it the blend out time. Next, we have this clear animating ability for all meshes. So basically, we're going to clear the animating ability. The good thing about naming the functions like this is that they're very straightforward what they're going to do. So we want to go ahead and cache a variable pointer to our Lyra gameplay ability class here. And we're going to cache using the ability that we pass in here. And then we want to iterate over that local T array that we have here. And for each of these, we want to check if the local data that we have saved for the animating ability is equal to the one that's passed into this function call here. If that's the case, we know that ability is of type Lyra gameplay ability. So we'll just go ahead and call our set current mesh, our set current montage for mesh on this ability. We want to pass it to mesh and basically null out the montage that gets passed through here. And then go ahead and set the animating ability to null pointer as well for the local data on this particular iteration that we're on. Next, we have this function here, current montage jump to section for mesh. And like I said, the names are pretty straightforward. We're just going to jump to a section for the current montage on this mesh. So the way that this happens, we do this select node style. I don't know what this is called. I think this is an inline. It's like an inline something. I can't think of the term for it, but it's very clever. So yeah, we set our anim instance with that. And then we go ahead and construct this local anim montage data and populate the variable with the local anim montage data that is coming in for the mesh that we pass through. And then basically if the section name is not equal to none, and we have an anim instance that's valid, and the local montage info, the local animation info has a valid anim montage on it as well, we want to go ahead and say anim instance jump to section. And then we want to use the section name that's coming in for this function call here, and the montage that we want to jump to section on, because this function here takes in a section name and a montage pointer. The montage that we want to pass in is the montage that is on that local animation montage data. And if we are on the server, if this component is on the server, we want to make sure that we update the replicated data so that we can queue this up to be replicated. Else, if we're the client, here we're going to call the server function to go ahead and say server update this to jump to the next section for other clients as well. This next function, what we want to do, and this is our current montage set next section name for the mesh. So these functions here, these jump into the section, set in the next section, and set in the play rate are very similar because these functions are basically meant to predict locally what we want to do, which is set in the next section, and then also replicate it up to the server. So here we're, getting our anim instance using this select style code here. Also constructing this local anim montage data here using this get local anim montage info for mesh, and then using that to determine whether we have a valid anim montage on this mesh that we're actually using for this function call, and if our anim instance came back valid. If that was true, we go ahead and jump to the anim instance and we call this montage set next section function. This function takes in an F name for the section name to change, the F name for the next section, and the montage that we're actually doing all of this section changing on. So we give it the from section name for the first parameter. The next section is the to section name. And then that montage is equal to the montage that we pulled off of this local data that we just constructed here. And if we're on the server, if this is already the server, we'll just update the replicated data. If we're not the server, if we're the client calling this somehow, we'll go ahead and create this constant float, call this current position, and we want to set this to the anim instance montage at get position. So this function takes in a montage and it returns a float that gets the play position of the montage. And we'll know this because as the clients, we called montage play predictively. So we want to get the location of where the montage is on the client so that when we send it up to the server, it's as close to in sync as possible. So yeah, we're using this montage that is cached in this variable here for the local mesh data. And I'm going to keep shortening this name because this is a long ass name and I don't want to keep on saying it. I'm already losing my voice. So then we're going to call the server current montage set next section name for mesh. And this function takes in the mesh that we want to do this on, the montage that we're doing this on, the current position of the client's version of the montage, and the section name that we want to start from, and then the section name that we want to go to. So we pass those all in. This next function, like I said, is similar to the ones on top. We're just but basically we're syncing up these predictive things that we can do on the client with the server. So here we get a valid anim instance using this select style code, and then we go ahead and cache this anim montage for mesh data here, pulling from the local data that we have stored on our mesh. And here, if that has a valid montage and we have a valid anim instance, we go ahead and say anim instance montage set play rate. And this is the function call that we're wrapping. This is the actual function that we wanted to call, but we had to wrap it and do it for the mesh that we want to do it for. So here we're using a anim montage pointer that we are using our local data here to pass in, and then this play rate, the new play rate that we want to set this montage to, we're pulling that in from the function call. And once again, if we are the server that's calling this, then we're just going to update the data. And if we're the client, we're going to tell the server, hey, go ahead and replicate this for us so everyone else can see that we changed our play rate from 1 to 2. This next function, we're checking if any ability is animating from any mesh. So what we're going to do is iterate over that T array of anim montage info for meshes. And remember, this thing stores a mesh, and it stores this local montage info, which stores this stores a lot of information. It stores the montage, the instance ID, the prediction key, and it stores the animating ability. So what we're doing is iterating over that, and then we're checking that local montage info to see if the animating ability is equal to the ability that we're passing in here. And we want to return true if that's the case. This next function, we are getting our animating ability from any meshes. So in this function, we're basically iterating over that local montage info that we have, that T array that we store here locally in the ability system component. And if this local montage info has a valid animating ability, then we want to return that animating ability. So once again, no matter what mesh is animating, we want to know if it is animating. So if any one of these return true here, if this returns true here, we'll go ahead and return that animating ability. If not, we'll return null pointer. This next function is going to get our current montages. This is going to return the T array uanim montage. So here we're going to construct the T array that we're going to fill once we iterate over that local montage info for meshes variable, the T array. And basically we're using this select style code to get an anim instance for the mesh that we want, which is the montage is the current montage that we're checking mesh. And then we want to see if that anim instance is valid. We also want to know if the anim montage on that local montage info property is valid. And we want to see if that montage is even active from that local montage info. If that returns true, we'll add that montage to this T array that we just created here. And then once that the iteration is done, we'll return all the montages. This next function, this get current montage for mesh, this is just going to return a single montage based off of the mesh that we passed in here. So we want to go ahead and use that select style code to get a valid anim instance. And then we want to construct this F game playability local anim montage for mesh. You see how long it takes me to say that? We want to construct one of those structs, and we want to populate its value with whatever comes back from this get local anim montage info for mesh function here. And then we're checking if our anim montage info, that local montage info property that we have on there, if it has a valid anim montage and we have a valid anim instance and we have an active montage from the montage that is actually being used for this local montage info. If that is active, we want to return that montage that we just used here inside of this right here. So this next function, this get current montage section ID for mesh, this returns int32. We're going to go ahead and grab that anim instance using the select style code. And then we're going to create a anim montage pointer, call this our current montage. And we're going to use get current montage for mesh and pass it the mesh that comes through this function call. And if our current montage is valid and our anim instance is valid, we're going to make a const float, call that montage position. And we want to set this equal to anim instance, the montage get position. So this function is on the uanim instance class. It just grabs the position, which returns a float. And we pass in the current anim montage that we're actually trying to get that position for. So now we want to return our current anim montage, and we want to get section index from position. So this function is on the actual anim montage, and it takes in a position and it converts that position to an ID for the section. And based on this value here, we'll return that proper section ID from that montage. If not, if this is invalid, we'll return a none index, which is basically enum, for -1. Okay, we're almost done. Okay, with these functions, we still got a lot more to go. So I'm gonna break this up into probably like 3 or 5 videos. This is a lot of code. So this next function, this is going to basically do what the function above did, but instead we're gonna return the section name. So it's a little bit different, and you can see I got a lot of green squigglies, meaning I can make these consts and that'll save on memory. So I'll probably go through and do that in my personal project. I'm not gonna do it here. You can make them const if you want to, but we're just gonna chug along. So here we get a valid anim instance based off of this select style code. Then we get the current in a montage by getting our current montage for the mesh that we're actually using in this parameter here, and basically checking if these two things are valid. And we get that montage position by calling to our anim instance and saying get position on this current montage here. And we go ahead and construct another const in32. This is the current section ID, and we're going to use this function on the anim montage that we just used up here to get the section ID here. And we're going to pass in our montage position that we just constructed there. And then we want to return this section name on this current montage here. And this get section name, it requires a section index. So that's why we constructed this section index. And this will return an F name for us. And if we fail here, we'll return an empty F name. Now this next function returns a float, and this just gets our current montage section length for the mesh. So we're getting a valid anim instance using that select style code. Then we want to get our current montage using our get current montage for mesh function here. And if those two things are valid, we want to go ahead and cache a const inst32 and call this current section ID. And we want to set this equal to our get current montage section ID for mesh, which we just did right here. And if this current section ID is not equal to index none, if it's not equal to -1, then we want this t-array of f composite section. And this struct, I believe, is how the montage organizes the section. So you'll see it in Blueprint if when I jump inside the editor to show you like how to set up a montage. You can set up these composite sections by just dragging in more and more animations into the montage. So this is a reference to this t-array, and we're calling this composite sections. And we're going to say current animation composite sections. So this will return all the different composite sections inside of this inside of this current montage. So if we have another section after us, then we take the delta between both of the start times. So basically this is doing some math to say if we have another section after us, we need to subtract the start times of our section that we're currently on and the start of that section. And this will return the float that we want, the montage section length. Otherwise, we just want to return the last section. So this will just return the length of the last section. And this will be easier to demonstrate in the editor when I have multiple sections in there, you'll see it. So if we have no sections, we'll just return the total length of the entire montage. So here we'll do that by, returning the current in a montage and calculating the sequence length. And if all of this fails here, we'll just return 0.0. And the last function that we're going to do for this video is this get current montage section time left for mesh. Of course, we're going to grab our anim montage. I probably should have made this like a function call right here. I'm not going to lie to you because I use it so much. So yeah, we'll get a valid anim instance using that select style code. And then we'll get a pointer to our current montage using our function here, get current montage for mesh. Then we want to check if the current montage is valid, the anim instance is valid, and we want to make sure that the montage that's playing is actually active, or the montage that we're checking is actually active, because it could be completely done and there's no reason to grab this float at all because it'll be 0. So then we make this const float for our current position, and we use the anim instance class's function call here to get the current position, or to get the position of the montage that we pass in here. And then we return the section time left from the position of this current position here. So we'll pass this a position that we are at in the montage, and it'll run the delta between the position that we're at and the end of the montage and return that as a float for us here. If not, we'll return -1 to say that this is invalid or something is wrong. So pretty much that's all I wanted to cover in this video. In the next video, we'll continue with the code. I'm looking at like if I show you guys my class here, it is well over 1,400 lines of code. So you see just how deep it could get for for just implementing new features. I want to put this out there to everybody who hits me up and requests me to do a new feature for them, or to like try to pay me like $300 to implement something for them. It really is a lot of work. And this is just me copying and pasting code that I already wrote. And this video is probably like 30 minutes long. So we're going to get out of here. In the next video, we're going to continue with this code base. So if you guys are ready for that, I'll see you in there. Peace.